Okay, let's now look at EJB. Just before talking about EJBs, we'll talk about J2E in general. J2E stands for Java 2 Enterprise Edition. Why was this introduced? Now initially we had only the JDK kit, that is Java 2 SDK. Later on J2E was introduced because once they started, the J2 SDK consisted of only core contents, like for core Java packages and for RMI and Java Beans. And once they started introducing the advanced topics like servlets, JSP, etc. Now, if we had to support for or write code for each one of these, and the servers had to support them in return. So each one would end up supporting to different versions of each of these softwares or each of these topics. Now what they did was they collectively put all the advanced contents together into a single package called J2EE. So now the servers specify that they support to J2EE version so and so, instead of saying servlet version this or JSP so and so version and let's say JDBC so and so version, right? So it's collectively known as J2EE version so and so is what the server supports. So that's how J2EE came about. Apart from J2 SDK and J2EE, we also have a J2ME package. So there are 3 kits now by Sun. J2ME is a micro edition, Java 2 micro edition, which has a set of packages used to develop code called midlets for your mobile's PDAs. J2E consists of the following components like Java Beans, JNDI, EJB, servlets, JDBC, JSP, RMI, RMI IIOP, JTS, JTA, and the list goes on like this. So these are just few of the components available in J2E. The JNDI stands for Java Naming and Directory Interface, JTS Java Transaction Service, JTA Java Transaction API. So the architecture of J2E and the specification of J2E goes like this. The J2E specification says nothing about how to implement the specification or how to implement the environment. So all the J2E specification says is when the components are written, how they should be written such that the container can handle the components. So the architecture of J2E basically consists of 3 contents. That is, you have the components, the services, and the communication. Of course, your components are nothing but your web components and enterprise components, which is servlets, JSP, and EJB. Your services are the various services provided for your components, like the database service, the messaging service, the security service, transaction service, etc. When we talk about communication, how do I communicate between components? and between services. So it is using RMI, IIOP, etc. The container architecture for J2E is the component, contract, declarative services. The container architecture consists of component contract, declarative services, container services, and other services. Now, what do I mean by component contract? It means to say that when I write a component, the component should adhere to certain rules, like such that the component can be handled by the container. Like, for example, you are writing a servlet should be derived from HTTP servlet or generic servlet. You are writing an EJB, it has to be derived from a particular set of interfaces. If you are writing an applet, for example, an applet should be derived from an applet class. This is the component container contract, so that the container can handle certain services for a component. The container services that are provided for a component are various services like the database service, the messaging service, security service, transaction service, etc. Now, although these services are provided by the container or is made available by the container for the component needs to tell the container which of these services it requires, and that is done through what is known as a deployment descriptor. So that is where the declarative services comes into picture. So declarative services is nothing but when you declare in your deployment descriptor what services that you want for your component, and only such services will be provided for that particular component. Then we have other services. Other services is like, for your component, instance pooling is done by the container. A number of instances for your component is created, and when each user comes in with a request for each client, one instance is allocated. So instance pooling is done by your container. Instance swapping is done, that is taking an instance allocated from one client and allocating to another client. So one other component of J2E which we have to talk about is the JNDI, Java Naming and Directory Interface, which we also referred in JMS. Java Naming Directory Interface is a namespace or a naming directory like your RMI registry, where you place remote objects. RMI registry acted like just a naming service, whereas JNDI is a naming and directory service. So therefore, in RMI registry, when you placed objects, you just specified a simple name. There was no hierarchy specified as such. Objects are placed on the root context of the registry. Whereas in JNDI, you can place objects at the root of the JNDI context, or you can give a directory structure under which you want to place the objects. By having to place under a directory structure, you can group together objects of similar type. That is the advantage by providing a directory structure. Now, before JNDI came out, there were already other naming and directory interfaces available. So why did we come out with JNDI? The reason is, let's say I am working with a Netscape server. So Netscape server has a naming and directory interface. Let's call it as NDS. Now your Java program that you are writing, the application, if it needs to talk to the naming and directory service, it has to use the API of NDS to communicate to NDS. Similarly, let's say WebLogic has what is known as a LDAP service, which stands for Lightweight Directory Access Protocol. And if I were to write a Java application which needs to talk to LDAP, I will use the LDAP set of APIs to talk to it. Let's assume now I want to take this particular application, port it to Netscape server. Then that part of the code which was referring to LDAP service has to change so that it can refer to NDS. So the code would not be completely portable because we are using API which is specific to that particular naming and directory service. So they introduced JNDI, which would sit out here it would be implemented by all the servers. My Java application then talks to JNDI instead of talking to a specific naming and directory service that the server provides with. So every server implements JNDI, and the JNDI in turn talks to the appropriate naming and directory service of that server. So therefore my Java application becomes independent of the service. Let us now look at Enterprise Java Beans, which is one of the component of J2E. Enterprise Java Bean, that is EJB, is a server-side component architecture. This consists of business logic for your application. This resides in your middle tier. EJBs run in containers which adhere to EJB specification. There are 6 different roles defined for EJB specification. They are the bean developer, the web or application developer, the server provider, container provider, deployer. So these are the 5 different roles defined by the EJB specification. The server provider and the container provider are the same. That is, they are the ones who implement the J2E specification. In return, the EJB specification. The server provider gives not only the server but also the container in which your component will run. So since both are provided by a single vendor, the understanding between the server and the container, that's a communication between the server and the container, is faster. The performance is faster. But imagine if the container was provided by one provider and the server by another provider. Then to communicate between the server and container in terms of performance, it decreases because of the understanding that has to go through between the server and the container that gets plugged into it. The bean developer is your enterprise Java bean developer, the one who creates your business components. And the web or the application developer uses the component built by the bean developer. The deployer will place your components onto the container or deploy your components onto the server. So these are the 5 different roles defined by EJB specification. Now let's look at what is the difference between enterprise Java beans and Java beans. Excepting for the name Java beans, they don't have anything similar. If you look at Java beans versus enterprise Java beans, a Java bean is a local object, which means to say that wherever I have written this component, although it's also a component architecture, wherever I have written this component, any class which is available locally can make use of it, which means the component should be residing with the application to make use of it. Whereas enterprise Java beans will reside in what is known as a EJB container. It's a different JVM altogether. And who uses this enterprise Java bean? It could be an application program or it could be a web application program. So which means they run in a separate JVM altogether. If we are talking about a web application program like servlets or JSPs, they run in a web container, which is a different JVM, and an application, plain Java application program, it runs in a different JVM as well. So since it's a communication between JVM to JVM, it has to be a RMI call. So therefore, enterprise Java beans are remote objects. Another difference is, we have already seen that a Java bean can be a UI based or a non-UI based, that is either a GUI based or a non-GUI based component. Whereas enterprise Java beans, as it resides in the middle tier, that's at the server, it is always a non-GUI based component. Another difference is, you can always convert a Java bean to a .ocx file or an ActiveX component, which you cannot do with a enterprise Java bean. So these are the differences between a Java bean and enterprise Java bean. They have totally different requirements. In order to write an enterprise Java bean, we have the following files involved in writing an enterprise application. So an enterprise application or you can call it as a J2EE application will have a deployment descriptor which describes all the components for you. A J2EE application consists of the following types of files. You could have a Java application which is a .jar file. You will have a bean component, which is your enterprise bean component, which comes in as a .jar file, or you can create a .ear file for it, which consists of 3 files: your home interface, a remote interface, and a bean class. And you could also have a web component or a web application, which is a var file consisting of servlets, JSP, applets, the GIFs, JPGs, the JS files, that is your JavaScript files, your HTML files, etc. They get into your web component. So, it is either your enterprise application is made up of jar plus the jar or jar plus the var. So, these are the files involved in writing a enterprise application. Now that we have seen what are the files involved in writing an enterprise application, let us look at who are the clients for EJB. Now, the clients for EJB can be a HTML client, a Java application client, or a non-Java application client. We have this server, the application server, which consists of a web container and a EJB container. It is in the EJB container where the beans are available or deployed. This is the web container. And this is the application server. The web container will consist of your servlets and JSP. The HTML client of course cannot talk to enterprise bean business logic straight away. HTML calls for a servlet or a JSP, which means it talks to a web container. And the servlet or the JSP in turn uses the beans for its business methods. The Java application of course can directly talk to a web, that is the EJB container, and the non-Java application can also call enterprise beans. Now, if you look at this scenario, you have a HTML client talking to a servlet or JSP. What is the protocol that it uses to call a JSP or a servlet? It is the HTTP protocol. Web container is a JVM, EJB container is a JVM. If a web container has to talk to a EJB container, that is, if I have to communicate between two JVMs, the protocol that we use is RMI. If a Java application has to talk to a EJB container, a Java application is also a JVM. A JVM talking to another JVM again is a RMI protocol. If I want to have a non-Java application talking to a JVM, that is a EJB container. So, then we go in for RMI IIOP protocol, that is Internet Inter-Orb Protocol. So, these are the different types of clients for the enterprise bean. Now, what is the difference between a web server and a application server? As we have seen, the web server consists of only the web container, whereas the application server consists of a web container, EJB container plus other services like the database service, the messaging service, the transactional service, security service, etc. are provided by the application server, which the container supports and provides to your components. Now, let us look at what are the different types of beans that the EJB specification has provided us with, and then we will look at the bean component files in detail. There are totally 3 types of beans that you can write in a broad sense, which are called as the session bean, the entity bean, and the message driven bean. The session bean is divided into 2 types: stateless and stateful. Entity bean is also divided into 2 types, that is the container managed persistence and bean managed persistence, otherwise known as in short the CMP and the BMP. The difference between each one of these beans are as follows. Session beans are used to represent the business methods, whereas the entity beans represent any noun. For example, employee, for example, order. So, any noun is represented by an entity bean. It represents a persistent data. Entity beans, since they represent data, they are known as persistent beans. Message driven beans are the JMS concept. This was introduced in EJB 2.0. It's a JMS concept in enterprise beans, where a message driven bean is generally written to receive messages, asynchronous messages. So, these are the 3 types of beans that are available. Now, let us take a more in-depth look at each one of these. Session beans, since it represents logic, there are 2 types of session beans, stateless and stateful session beans. A stateless session bean does not hold any client state or client information. So, when you write a session bean which does not have any data representation for the client, that is having any instance members in the session bean class for the client data, it is a stateless session bean. You would not represent the data there, because amongst the methods that you define, the business methods in the session bean, stateless session bean, there is no conversation between them, there is no interlink between them, no data getting passed between them. So, such a bean is called as a stateless session bean. Like for example, you might have a business logic method to print a report. Another method could be to display a Fibonacci series, but there is no relationship between these methods. So, that is called as a stateless session bean. Stateful session bean is also known as a conversational bean. Because the methods in a stateful session bean can be interlinked. For example, a set and a get method, because there is a state for the client being maintained in a stateful session bean. That is why it is called as stateful. Client state is being represented out here, and this client state can be accessed across the methods of a stateful session bean. Entity bean, as it represents data, it is also known as a persistent bean. There are two types of entity beans: container managed persistence and bean managed persistence. The name is so called because in case of a CMP, the data out here, first of all, in entity beans is represented in the database. The data is stored in the database. So, entity beans are long lived, whereas session beans are short lived. Although in a stateful session bean you are storing the client information, it is only in the variables, so therefore it is only in memory. If the server goes down, you lose the information, that is the client state. But whereas entity beans, since it is a persistent bean, you are storing the information into a database, it is long lived, because even if the server goes down, you can retrieve back the information from the database. And who is going to handle the persistence? Depending on whether you are going to write a CMP or a BMP. If you are writing a CMP, it means the container will take care of persisting the information to the database. So, you need to declaratively tell the container what it needs to persist and where. Whereas in case of a BMP, since it is bean managed, in your bean class, you have to write the JDBC code to persist the data into a database. So, these are the differences between a session bean, entity bean and a message driven bean. Now, let us look at how to write a bean component and what are all the files involved and how exactly it works. Then we will move on to the life cycle of each of the types of beans. Now, in case of a enterprise Java bean, there are three files involved, we said. They are called as home interface, remote interface and the bean class. So, we have the home interface, remote interface and the bean class. The home interface would be derived from EJB home. The remote interface is derived from EJB object, and the bean class implements, depending on the type of bean that you are writing, either a session bean, entity bean or a message driven bean. It depends on what type of bean you are writing, and appropriate interface should be implemented on the bean class. This is the container component contract. Now, remember that enterprise Java bean is a remote object. So, if a client needs to access a remote object, we always require to have a remote interface, and the remote interface declares all the methods, the business methods which the client can access. So, the remote interface that we are going to define will have all the business logic methods which the client can invoke. How is this interface a remote interface? What makes an interface a remote interface? When you derive it from java.rmi.remote, that is what makes your interface a remote interface. This is what we also mentioned in our RMI class. But we are actually deriving this interface with EJB object. So, how does it make it a remote interface? That is because this EJB object is an interface which is derived from RMI remote. So it makes it a remote interface. Next, in case of enterprise Java Beans, a client cannot access the remote object directly, unlike we did in RMI. Remember, in RMI we had a remote interface, we had a class which would implement the remote interface and implement the business methods of the remote interface. The client would directly look up for the remote object itself to the RMI registry, then invoke the methods. EJBs are highly secure. So therefore, you cannot access enterprise beans directly via the remote interface. They have to be accessed through container generated methods. And these container generated methods are nothing but the methods of the home interface. The home interface consists of methods like create, remove, and possibly, depending on the type of bean, that is, in case of entity beans, it also consists of the finder methods. The create and the finder methods return a remote interface type of object. Now, these methods will be implemented when we compile using what is known as a EJBC command, EJB compiler command. You are not going to implement this home interface on any class of yours. You are just going to declare the methods in the home interface, telling it what type of a remote interface object it needs to return. So it will be implemented later in time when you compile. So that's why these methods of home interface are called container generated methods. And through these container generated methods, you access the remote objects, that is, objects of type remote interface. The bean class implements the lifecycle methods of the interface that it is going to be implementing, and also the methods of type the remote interface. So you will have B1, B2, etc. whatever business methods you might have declared in remote interface, and also the callback methods of the interface which you have implemented. For example, the EJB create method, EJB remove method, set context method, etc., which are all callback methods from the interface that you would be implementing. We will come across these callback methods more in detail later. Since the client is going to access the remote object via the home interface method, and the home interface and its implementation would also be residing at the server side itself, not at the client. So the client has to get the object of type home interface in order to invoke these methods. The home interface object is also a remote object. How do I know it's a remote object? It is derived from EJB home. EJB home in return is derived from RMI remote. So therefore, home interface object is also a remote object. The client would be looking up with the JNDI name, which we call it as in general the bind name in RMI. Here we call it as a JNDI name because we are going to create these objects, place it into a JNDI. Okay. So the client will look up for the JNDI name, and that is a JNDI name for the home interface as such. So when we do a lookup for the JNDI name, we get an object, we need to downcast it to a home interface type and invoke the method using that object. Since this method is a remote method call on a remote object, any remote method should use throws of remote exception. Apart from that, the create method, if it is unable to return you the remote interface type of object, it will also throw what is known as a create exception. So all these methods must use throws remote exception. And create exception in case of finder method as well. The methods of remote interface are also remote methods. So any methods of remote interface should use throws of remote exception. The bean class, we said, implements the methods of type remote interface, the business logic methods. We never mentioned till now that we are going to implement the remote interface on the bean class. It's only one of these type of bean interface, enterprise bean interface. These methods therefore need not specify, need not specify throws remote exception, because it's not a direct implementation of the remote interface. The bean class will not and should not implement the remote interface, but it will implement the methods of type remote interface, and these methods need not specify therefore throws remote exception. Why is it that we are not implementing the remote interface on the bean class? And also, who is going to implement the remote interface? Now, just like we have a container implementing the home interface class called, let us say, called as home object class, we refer it to as a home object class, which would actually implement the home interface. This is actually generated when we use the EJBC command. Similarly, at the same time, there is a EJB object class which is getting generated. Again, therefore, this is being implemented by the container, by rather the EJBC command. So there would be a class, let us call it as EJB object, that is what we refer it by. This will implement the remote interface, and this would also extend the bean class. So the client actually looks up for the home interface type of object onto a JNDI, gets the home interface object, calls the create method which returns a remote interface type of object, which means it's nothing but an object of this class type. Rather, it's the stub of the remote interface which gets returned. Now, once we call using the remote interface object the business method, remember that this EJB object class, since it's implementing the remote interface, it implements public, whatever the signature, the business method, throws remote exception, opens the bracket. So this is a direct implementation of the remote interface method now. In turn, this calls the B1. So this B1 is nothing but the parents, the bean classes business method implementation. So therefore, when the business method is invoked using the remote object which you fetch from the create or the finder method, the business method which you defined in the bean class gets executed in return. So this is how the mapping is done. But why are we doing or going through this indirection? why is the container actually generating the class for me rather than I implementing the interface on the class directly here? It is because this remote interface is extending from EJB object. EJB object also has certain methods declared in them. EJB object is not a marker interface, and the methods of EJB object has to be implemented by the container itself, and all these methods have to be implemented with the networking issues. So this has to be done by the container or the EJBC command. Therefore, we do not implement the interface on our bean class and implement the methods directly. Now that we know how the classes are written and why they are written so, let us now move on to finding out the life cycle of each of the types of beans. Now that we have seen the different classes that get generated and that we write in order to build an enterprise bean component, now let us just note one more thing out here, that the EJB object and the EJB home classes are actually your remote object classes. So during the generation of EJB home and EJB object classes, right after them, it will also create the stub and skeleton classes for those particular classes because they are the remote objects. Now let us look at the life cycle of each of the beans. We have seen that stateless session bean is used to process a single method at a time, and stateful session bean is used to perform multiple method calls. So span multiple method requests or transactions. That's why it was called as a conversational bean. Now let's look at the life cycle of a stateless session bean. For a stateless session bean, the life cycle goes like this. Starts with the does not exist state, moves into a pooled state, and then to a ready state. So here a new instance is created, set session context is called. The context identifies the type of bean and it initializes the environment. From the context, we can find out details regarding the authentication as well as the type of objects, the home object of the component, the remote object of the component. So set session context is called. Then using the set, after that EJB create is called, or the EJB create method is called by calling a create method. EJB create comes from the bean class, which is a callback method which gets called when the create method is called. Once it's in a pooled state, then whenever a method call comes in, an instance from the pool is allocated to execute that particular beans method. To move from a pooled state to a does not exist state, EJB remove and finalize methods are called. This is the life cycle of a stateless session bean. Now let's look at what exactly happens here. You have a client the client is going to first of all do a lookup for the home interface using the JNDI name. So client calls a lookup of the JNDI name. This gets sent to the JNDI, which actually talks to the underlining directory and naming service, which in case of WebLogic is a LDAP service. The JNDI will return back the home object type, home interface type of object. So I have a home stub here at the client. Using the home stub, we call the create method. When we call the create method on the home object at the server side, we have a pool of instance of your stateless session bean. The create method talks to the home skeleton, which then picks up an instance from the pool, and here we have a remote skeleton with which this instance would be associated, and then returns back to the client with the home stub type of object. Then the method call occurs between the remote stub and the remote skeleton. This is how the call works when a client makes a request. Now let's assume another client comes in. Let's say client 2, who also wants to access the same remote object. What happens in this case is, again it would pick up an instance from the instance pool and allocate it. But before it can allocate another instance, it will check whether the instance that has been allocated for this particular client is being used. If it is not being used, then it disassociates this object from the client and gives it to this particular client. And when this client comes back with a method call, another instance either from the pool or again swapping the instance from another client, it will allocate an instance for the method call. So this disassociating an instance and allocating that instance to another client is called as instance swapping. In this case, the instance does not hold any client specific information. So we need not worry about having to disassociate an object and allocate it to another client in any manner. In case of a stateless session bean, since there is no client state being maintained, the create method of the home interface would be a default create method, which means it's a no argument method. And this is the only create method that we write for the stateless session bean. So therefore, the EJB create method, which is an associative method for the create, we said when a create is called, EJB create is also called. So when the create is invoked, the callback method EJB create will be executed using this instance. Now, if that is the case, then I need to have an associative EJB create method in the bean class for every create method in the home interface. So we have a default EJB create method which does not take any argument in the bean class in case of stateless session bean. Now moving on to stateful session bean life cycle. In case of stateful session bean, since there is going to be a client state being maintained, the client, while calling the create method, can pass parameters. So because of this reason, the instances are not pooled. Stateful session bean, there is no pooling done. An instance is created, set session context is called, EJB create is called, it's in a ready state to execute the method call. Then EJB remove is called, it goes into a does not exist state by calling a finalize on the object. In case of a stateless session bean, since there can be overloaded create methods, the container will not know how to initially create an instance and keep it in the pool, because EJB create, that is the EJB create method would have already been invoked if it has to be pooled in case of a session bean. So therefore it cannot create instances beforehand, it will create as and when required. So in a stateful session bean, when a client looks up for the home object, gets the home object, that's the home stub, calls the create method, an instance is created and allocated for this client. With its remote skeleton, and a remote object type of reference is returned. Then when the method call is made, upon this instance the method, using this instance the method is invoked. Now let's say another client comes in. For this client again another new instance would be created and the method call is executed. But before it can create another new instance, again it will check whether the client for which an instance has already been allocated and associated, whether that client is utilizing that object. If he has not touched upon that object for some time now, then again instance swapping occurs. During the instance swapping, now since it's a stateful session bean, there is a client information being maintained. So when I swap an instance, I have to take care that I don't pass one client information to another client. So what happens during instance swapping in stateful session bean is that before I can swap this instance to another client, I need to store the information of this instance into the memory which would be associated with that particular client skeleton. Then this instance content, when you are storing into memory, it is called as EJB passivate. So I passivate the data, that means I am going to store the state of an object into memory, then nullify the content of the object, disassociate it with this client and associate with the new client which comes in with a request. So now this instance has the state of the new client. When this client comes back with another request, again either through instance swapping or creating a new instance, instance is associated again with the skeleton, and then the data from memory has to be read back into the object. That is, it would have serialized the content of the object, it needs to deserialize back into an object. That is called as EJB passivate. Sorry, EJB activate. Reading back from memory back into an instance is called as EJB activate. Storing the state of an object into memory is called as EJB passivate. So in case of stateful session bean, EJB activate and EJB passivate also occurs. These are callback methods coming from the session bean interface. So in this case, rather, so in case of stateless session bean, the EJB passivate and activate will not happen. But since this comes from the session bean interface, which you will implement regardless of if you are writing a stateful session bean or a stateless session bean, these methods would be implemented as do nothing methods. That's about a stateful session bean life cycle. Now let's look at an entity bean life cycle. Whether it is a CMP or a BMP, regardless of it, it's the same life cycle. In case of an entity bean, the life cycle starts with does not exist state, it moves from there to the pooled state, from the pooled state to a ready state. From the does not exist state to a pooled state, it goes as follows: a new instance is created, set entity, context is called, then it moves into a pooled state. From the pooled state to a ready state, it moves down by EJB create. When we call a create method, it calls EJB create, and also we have EJB post create, and from the ready state to a pooled state by calling EJB remove. Again, we can move from pooled state to a ready state by also calling EJB find by primary key. Or your EJB finder methods. We also move to a pooled state to a ready state via EJB activate and EJB load method. Similarly, we go back from a ready state to a pooled state by calling EJB store and EJB passivate method. When it moves from a pooled state to a does not exist state, it calls the unset entity context and finalize. This is the life cycle of an entity bean. Now let's look at more in detail. In case of an entity bean, instances are created and pooled. So we have pool of instances. Since entity beans are persistent beans, they represent data in the table. One entity bean represents one row in a table. How does it represent one single row? How does it uniquely identify that row? It is through the primary key. So for every entity bean, you need to have a primary key. So you will have a create method for entity bean at least by passing a primary key field. If you want, you can pass any other fields along with that. So therefore, even in entity beans we can have more than one create method. Again, for every create method I need to have an associate EJB create method in the bean class. So when the create is called, the EJB create methods are invoked as callback methods. So first thing that happens is, from the does not exist state, a new instance is created, set entity context is called, and it goes into a pulled state. When you call EJB create, you are passing the primary key. So EJB create, the create also takes primary key. EJB create also takes therefore the primary key as parameter. That's the minimum requirement. The create method of the home interface returns the remote interface type of object, whereas the EJB create method for entity bean, it returns a primary key field type. It is not void, whereas in case of session beans, the EJB create method return type is void. In case of EJB create method of entity beans, it returns the primary key field type. So the primary key field has to be an object type. So if you are having a key field as a primitive data type, you need to specify it as a wrapper class object type. If suppose a primary key field is a composite key, that means to say it is made up of more than one field, like assume first name and last name together is supposed to be a primary key. Whenever a primary key is a composite key, then you must define a class for the primary key, and that primary key class should declare all the variables which make up the primary key, and you should create an instance of this class to specify it as a primary key field object type. Once the EJB create method is called, the EJB create method, as we mentioned, returns the primary key field type. In case of a CMP, the EJB create will return a null, whereas in case of a BMP, EJB create will return the primary key field value. In case of CMP, we return null because the container has to return the key field for us. It's the container which is actually maintaining the persistence. Whereas in BMP, since we are maintaining a persistence, from EJB create we ourselves will return the primary key field value. Why do I need to return a primary key field if my EJB create itself is taking a primary key field value? This is because later on, during the EJB passivation, for example, I am going to store the information, and when I need to retrieve back the object, let's say, I need to know which is the primary key field for which I need to retrieve back the information from the table. So I need to associate my skeleton with the instance, the primary key field. This is just one example where we need to, for later usage, make use of the primary key field. So we return that primary key field to the container so that it associates our skeleton with that primary key field. Once the EJB create method is done with, EJB post create method is called. In the EJB post create method, you can access the object of the bean, because till the EJB create is done with, the instance is not ready because it's not yet returned the primary key. So it's not yet associated as such the instance. So suppose you have a requirement, like for example, you have bean 1 and bean 2. For bean 1 you want to pass the reference of bean 2. You can do it in the EJB post create method. So anything that has to be done once in a lifetime of the bean instance, once the instance is ready, can be taken care in the EJB post create method. Then the object is ready for method invocations. Now coming back here, the client requests for a home object. Using the home object calls the create method. The create will access an instance from the pool and return that instance to the remote skeleton. After which it will return, it will actually call the EJB create and post create method using this instance, and then return the remote stub for the client. Now upon the remote stub, the client then invokes a method, sends it to the remote skeleton. The remote skeleton returns back the result to the remote stub. So this process goes on. Let's say another client comes in with a call to the same remote object. Then again, before allocating the instance from the pool, it will check whether the allocated instance with other clients is being utilized. If not, instance swapping is done. Otherwise, it will pick up an instance from the pool and allocate it. Now just before the instance swapping can be done, again here in entity beans, client state information is being maintained. The data is going to be persisted, that state information. So it needs to serialize the object state. Rather, it needs to persist the object state in this case. It will write the content to the database. This is called, again, when it writes the state of an object to the database, it is called as EJB passivate. There would be a method called EJB store, which is a callback method which gets executed, and then EJB passivate will get executed. So once the passivation occurs, the object is nullified and then it allocates that instance to another client. Now when this client comes back with a request, an object has to be allocated either by instance swapping or picking it up from the instance pool again. Once the instance is associated, then we need to read back the data from the database again back to the instance. Now at this point it's called as EJB activate. So EJB activate, during the activation process, EJB activate is called, and again another callback method that's called EJB load is also invoked. When the user calls EJB remove, it places the instance back into the pool. Since there is a primary key involved with the database, and you would probably see when you call a create method, it's an insert to a database. What if you want to fetch a record which is already in a database? How do you fetch it? You use the finder method. For every entity bean, there must be a finder, at least one finder method available, provided that is, and that finder method is called as find by primary key. Find by primary key is a method in the home interface, and EJB find by primary key is a method in the bean class, which is a callback method. The EJB finder method for the finder method in the home interface will not be implemented in the bean class in case of a CMP. The container will implement the method for it. You will not write the associative EJB finder method. Whereas in case of a BMP, you need to write the associative EJB finder method. And again, the finder method in the home interface will return a remote interface object, whereas EJB finder method will return a primary key value as a return value. Apart from find by primary key method, which takes only one parameter, that is the primary key field, you can have other user defined finder methods in the home interface, which means you need to have associative EJB finder methods in the bean class. And again the same rule follows. If it's a CMP, you do not write the EJB finder methods, If it's a BMP, you write the EJB finder methods as a callback method in the bean class. So EJB finder methods also bring the life cycle or the object to a ready state, so you can invoke methods on it. This is the life cycle of a entity bean. Just one more point to be noted is that in case of stateless session bean, objects are priorly created and placed in the pool. The objects of stateless session bean can be shared across all clients, since there is no state being maintained for the client. Another thing is, what exactly happens during EJB create? An insert to a database occurs in case of EJB create. EJB load, since we are going to read it from the database, it's a select. EJB store is an update to our database. EJB remove is a delete to the database. EJB finder methods are also select from the database. One more thing to be noted out here with entity beans is that when a client gives the same primary key field value, then the same instance is associated with both the clients. All those clients who give the same primary key field value, they share a single enterprise bean EJB object.